All right, so the overall goal of this project is to understand the sediment sources and transport distances of sedimentary particles in the Big Walnut Creek watershed. So what we're doing here today is we're getting a soil sample from an area that is at relatively high elevation, and these soils around us actually serve as the source area for the suspended sediments that undergo transport in Big Walnut Creek following a heavy rainfall event. What we're doing is we're using fallout radionuclides that occur naturally as fingerprints on our sedimentary particles. So today what we did is we've got some soil cores from this area, and we're going to take them back to the lab and we're going to section them, we're going to analyze them for various radionuclide concentrations. What we'll do then in the future is when there's a heavy rainfall event on the watershed, we'll actually go and collect water samples from Big Walnut Creek, and we'll measure the radionuclide fingerprints on the sediments that are being transported during that high rainfall event. We'll be able to compare that radioactive fingerprint with the radioactive fingerprint that we see here. And we're going to repeat this at a number of locations in the watershed, and the hope is that we'll be able to figure out exactly where the sedimentary particles in Big Walnut Creek are coming from and how far they're actually moving every time there's a rainfall event and they undergo transport. This is the slot core that we call that we just got out of the ground here from this pit that I'm standing in. When we get it back to the lab, what we're going to do is we're going to very carefully section it into very fine increments, and we'll take every increment and we'll analyze it for the radionuclide concentration, and that way we'll build a radioactive fingerprint for this particular core based on our analysis in the lab. The final thing we do, we want to make sure that we get the entire fallout radionuclide inventory. And in most cases, it's confined to the top 30 centimeters of the soil profile, which is what we have collected here in this device. But just to be sure that we're not missing any of it, we take a number of hammer cores from the bottom where we stop sampling here deeper into the soil. And then we will analyze those deep cores to see if there's any fallout radionuclides that have come out of the atmosphere that have managed to pass deeper into the soil profile. What we want to make sure of is that we don't miss any of the radionuclide inventory that's in the soil.